Okay, I want you to imagine being frozen. I mean, completely frozen, but not by ice, by your own brain. Today, we're going to try and unlock one of the most mysterious syndromes in all of medicine, catatonia. Now, it's a word that probably brings up some really chilling images, right? But the reality, well, it's so much more complex. And honestly, as you'll see, it's also deeply, deeply human.
I mean, listen to this. A young man who was in a catatonic state was asked a simple question: Are you suicidal? And his answer was, why should I? I'm already dead. That just gives you a chilling peek inside a mind that from the outside looks completely shut off. But it's not some empty void in there. For so many people experiencing this, it's a very active and often a really terrifying internal world.
So that brings us to the big question, right? What is catatonia, really? If we can just, for a minute, push past all the stereotypes we've seen in movies, what does the actual science, the real clinical experience, tell us is happening here? All right, first things first. Let's talk about the image that everyone thinks they know. You know the one. It's the picture that, for more than 100 years, has pretty much defined catatonia for most people: this mysterious, frozen immobility. Yeah, this is the classic picture, isn't it? You imagine someone totally unresponsive, maybe holding some bizarre pose for hours on end. And look, that can be part of it. But here's the fascinating part, and this is really important. That's just one tiny piece of a much, much bigger puzzle. In fact, and this might surprise you, most people with catatonia can actually speak and move. Thinking they're all just frozen like a statue, that is the single biggest mistake people make about this condition.
Okay, so if it's not just about being frozen, then what else is going on? Well, this is where things get really interesting. This brings us to the many, many faces of catatonia, and you'll see just how true and honestly how contradictory this syndrome can be.
Here's the key thing to remember. Catatonia isn't just one thing. It's what we call a syndrome, which is really just a collection of different signs that can show up in all sorts of ways. I mean, researchers have identified more than a dozen different features. And believe me, they can get really bizarre, sometimes contradictory, and totally counterintuitive. So let's look at a few of the most striking ones.
First up, we've got something called echo phenomena, and this is just wild. This is where a person will automatically, involuntarily mimic what they see or hear. So if you raise your arm, they'll raise their arm. If you ask a question, they might just repeat the question right back to you. And it's not a choice. You know, it's a completely involuntary, almost puppet-like response. And then there's something called negativism. Now, we need to be clear, this is not just someone being stubborn or difficult. It's an almost reflexive, automatic opposition to, well, everything. You ask them to open their mouth to eat, and their jaw will clench shut. You try to help them get into bed, and they might lie down on the floor under the bed instead. It's a true clinical sign that the brain is misfiring, not some kind of behavioral issue.
And then we have the one that really fuels that whole frozen stereotype: waxy flexibility. This is where you can gently move a person's arm, say, into a new position, and they'll just hold it there. Like, just hold it. For minutes, sometimes even for hours, almost like they're a living mannequin. It's this really strange type of catalepsy where the body just holds a posture for absolutely no reason. So, with all these strange symptoms, what's the first thing that comes to mind? For decades, the answer for pretty much everyone was one specific illness: schizophrenia. I mean, the term catatonic schizophrenia is practically burned into our culture. But is that connection actually true?
Well, it turns out, not even close. In fact, a landmark study back in 1976 completely flipped this whole assumption on its head. Just look at this chart. A staggering 71% of catatonia cases were actually linked to mood disorders, things like bipolar disorder and severe depression. And schizophrenia? A tiny 7%. And this wasn't some fluke study either. This has been proven over and over again. The takeaway is huge. Catatonia is primarily a feature of severe mood problems, not psychosis. And that discovery, well, it changed everything.
Okay, so we've established we have this really complex, really misunderstood syndrome. But here's where the story takes a turn, because this is the good news. It is remarkably treatable. I mean, the change can be so fast and so complete, it's like watching someone literally wake up right in front of your eyes. So, one of the most effective first-line treatments is something called the lorazepam challenge. Now, lorazepam is a pretty common anti-anxiety medication, but its effect here can be absolutely stunning. I mean, look at this comparison. Before the medication, you have a patient who is mute, they're in a stupor, totally immobile. Then, within hours of a single dose, that very same person can be verbal, active, mobile, and even asking for a glass of water. The transformation is often that fast and that dramatic. And when that doesn't work, there are other really powerful options. Electroconvulsive therapy, or ECT, has been a safe and incredibly effective treatment for catatonia for more than 80 years. And here's a little piece of history for you. The very first patient ever treated with modern ECT way back in 1938 was a man with catatonia. And guess what? He made a full recovery. The fact that catatonia responds so dramatically to these treatments, well, that gives us massive clues about what's actually going on in the brain. This tells us it isn't some abstract, untouchable mystery of the mind. No, it's a physical problem. It's an issue with the brain's actual wiring, its circuitry. So what's the actual mechanism? I mean, how can the brain, the very thing that controls a living, breathing, thinking person, just lock up like that? And maybe even more amazing, how can a simple pill unlock it all again? Well, the leading theory is that catatonia is basically a failure of the brain's motor circuits. And probably the best way to think about it is like a car's emergency brake. It's a critical safety system designed to stop all movement, right? Well, in catatonia, it's like that emergency brake gets slammed on hard, but then the release mechanism gets stuck. The stop signal just completely overwhelms the go signal. And what's really cool is we think we've identified the specific circuit involved. It's a critical control loop in the brain that works kind of like this. It starts in the cortex, that's where you initiate a thought or an action. Then that signal zips over to the basal ganglia, which helps select and fine-tune the right movement. From there, it goes to the thalamus, which is kind of like a filter or a gateway, before it sends the final go command back to the cortex. This loop is essential for literally everything, from picking up a cup to saying a sentence. In catatonia, this whole system just grinds to a complete halt. And if we zoom in to the chemical level, it all comes down to neurotransmitters, the brain's chemical messengers. There seems to be a major imbalance. The number one suspect is a neurotransmitter called GABA. Now, GABA is the brain's main brake signal, and in catatonia, it looks like GABA function is way, way down, which, kind of paradoxically, causes the whole system to just seize up. This actually explains perfectly why lorazepam works so well. It boosts GABA's effects, which is like putting your foot on the brake pedal to release that stuck emergency brake. Okay, so we've got a pretty clear picture of a brain circuit gone wrong, but that just leads to an even deeper, more fascinating question. Why? Why does our brain even have a circuit that can fail in this specific, catastrophic way? And the answer, well, it might be the most profound insight of all. It seems to be an echo from our deep evolutionary past. Think about it. Is this just a disease, a random glitch in our wiring? Or could it be something else entirely? Something almost purposeful, a deep, primal program that's been baked right into our DNA for millions and millions of years. The clue, it turns out, is all around us in the animal kingdom. It's a powerful defensive reaction called behavioral arrest. When an animal is faced with an overwhelming threat, like a predator it can't escape from, it often doesn't fight or flee. It freezes. It becomes completely and totally immobile. It's the ultimate last-ditch survival strategy. Play dead or just hope you go completely unnoticed. And this brings us to the core mind-blowing idea. What if catatonia isn't a malfunction at all? What if it's the human brain, completely overwhelmed by extreme psychological or physical stress, defaulting to its oldest, most primitive survival program? It's a process called dissolution, basically a regression back to this ancient state of protective immobility. The modern thinking parts of our brain shut down, and this ancient, hardwired freeze response just takes over everything. I mean, this reframes everything, doesn't it? As one psychiatrist so powerfully put it, if suicide is the ultimate separation solution to intense melancholic pain, catatonic stupor is the penultimate one. It suggests that catatonia isn't just a random list of symptoms. It's a desperate final attempt by the brain to solve an unbearable problem by simply shutting down. A state that is, in its own terrifying way, a kind of death before death.